Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning a bit about electricity, the invisible force that powers our entire world. But before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. People say that if you're in a car during a storm, you'll be safe from lightning because the car's big rubber tires act as insulators. It seems to make sense because rubber doesn't conduct electricity, but is that enough insulation to protect you from a bolt of lightning? We'll find out at the end of the episode. Now for your word of the day. Our word for today is electron. That's E-L-E-C-T-R-O-N. An electron is a stable subatomic particle that has a negative electric charge. These tiny particles are found in all atoms, and they're the primary carriers of electricity in solids like the copper wires in your walls. When we talk about current, we're talking about the flow of these electrons. The word electron was coined in 1891 by the Irish physicist George Johnstone Stoney. He based it on the ancient Greek word elektron, that's spelled E-L-E-K-T-R-O-N, which means amber. And why amber? Well, over 2,500 years ago, the ancient Greeks observed a strange phenomenon. They noticed that if you rubbed a piece of amber, which is fossilized tree resin, with a piece of fur, the amber would suddenly be able to attract light objects, like feathers or bits of straw. This was humanity's first recorded observation of static electricity, so that original Greek word for amber is what gave us electron, electricity, and electronic. Time for your daily high five, our top 5 fun facts about electricity. And number 1, some animals are basically like living batteries. Electric eels are famous for their shocking ability. They have 3 special organs that take up most of their body. These organs are made of thousands of modified muscle cells called electrocytes, which are stacked up like the cells in a battery. When an electric eel wants to attack prey or defend itself, its brain sends a signal that causes all those cells to discharge at the exact same time. This coordinated blast can release a jolt of up to 860 volts, which is more than 7 times the voltage of a standard US wall socket. But it's not all or nothing. They can also use weaker pulses of just a few volts to navigate their murky water environment, using the electric field like a kind of radar, a sense called electrolocation. And here's another interesting fact about electric eels. They're not actually eels. They're a type of knifefish found in South America, and they're more closely related to catfish or carp. And number 2, humans may have harnessed electricity 2,000 years ago. When people talk about the early origins of humans harnessing electricity, they often credit people like Benjamin Franklin and Alessandro Volta, who first invented the modern battery. But archaeologists in the 1930s found mysterious objects in Baghdad, Iraq, that caused everyone to rethink that timeline. They're called the Baghdad batteries, and they're 2,000-year-old clay pots, each containing a copper cylinder and an iron rod sealed with an asphalt plug. When these pots are filled with acidic liquid like vinegar or grape juice, which were readily available back then, they produce a small but noticeable electric current. We don't know for sure what they were used for. Some scientists theorize they were used for electroplating, coating jewelry with a thin layer of gold or silver, while others suggest they were used for medical electrotherapy or even as a magic trick or in religious rituals. Regardless, it would appear that batteries and electric power are way older than you might expect. Number 3. The real speed of electricity is actually surprisingly slow. When you flip a light switch, that signal to turn on the electric field does travel through the wire at nearly the speed of light. This is why light appears to turn on basically instantly. But the actual electrons themselves, the physical particles carrying the charge, are just bumping along. They move at a surprisingly sluggish pace called drift velocity, which is often less than 1 millimeter per second. Think of a garden hose that's already full of water. When you turn on the tap, water comes out the other end immediately, but the first drop of water from the tap hasn't traveled down the hose yet. It's just the water that was already filling the hose being pushed out. The wire is already full of electrons, and the switch just gives a push to the ones at the start, which pushes the ones at the end. Number 4. A lightning bolt, nature's electrical discharges, are actually hotter than the sun. Inside a turbulent storm cloud, a massive electrical charge builds up. This happens when tiny, light ice crystals are pushed up to the top of the cloud by updrafts, gaining a positive charge. At the same time, heavier, negatively charged water droplets and soft hail fall to the bottom. This separation turns the cloud into basically a giant battery. When the charge difference becomes too great, it discharges as a bolt of lightning, releasing an incredible 5 billion joules of energy in an instant. That energy superheats the air in its path to 54,000 degrees Fahrenheit, or about 30,000 degrees Celsius. To put that in perspective, the surface of the sun is about 10,000 degrees Fahrenheit, or 5,500 degrees Celsius. This extreme heat, about 5 times hotter than the sun's surface, causes the surrounding air to expand explosively, creating a powerful sonic shockwave that we hear as thunder. But such extreme heat can't last for too long. It dissipates in just a few microseconds. That's millionths of a second. And our 5th and final fun fact for today: Benjamin Franklin didn't discover electricity, but he did invent the lightning rod. There's that old story of Benjamin Franklin flying a kite in a thunderstorm, and many people have this mistaken notion that he conducted that experiment and discovered electricity, but he wasn't trying to discover electricity. People have known about that for thousands of years. If anything, he was really just trying to prove this idea that lightning is electricity. And also, just a side note, such an experiment would be extremely dangerous. Do not try it. But Benjamin Franklin and his ideas about a kite and a key and a lightning storm did lead to probably his greatest practical invention, the lightning rod. Franklin realized that if lightning is just a big electric spark, you can control it. He designed a pointed metal rod that could be attached to the top of a building and connected to a wire running safely into the ground. You might say that despite all that energy, electricity can be a bit lazy and takes the path of least resistance. When lightning strikes, it's drawn to the rod that conducts the electricity, and the electrical charge is harmlessly guided away from the building, preventing fires and damage. Now, on the topic of safety around electricity, we all know electricity and water don't mix, but here's a little bonus fun fact for you. Pure distilled water is actually an electrical insulator. It sounds completely wrong, but it's true. We think of water as a great conductor, but pure H2O itself is actually not. For electricity to flow through a liquid, it needs to be carried by charged particles called ions. Pure distilled water has virtually no free ions, so it's a very poor conductor, acting instead as an insulator. The thing is, we rarely encounter pure water like that. Tap water, rainwater, lake water, and especially pool water are all full of dissolved minerals, salts, and other impurities. Those tiny particles are what provide the ions, turning everyday water into the dangerous conductor we all know. Now for some news you can use. If you want to gain a better understanding of electricity, try exploring paper circuits. You can find materials like copper tape, small LED lights, coin cell batteries, those little flat round ones. They're all pretty cheap online. With just a few simple items, a piece of paper, you can create your own light up greeting cards, origami, or my personal favorite project to do with the kids, making light up constellations. The peel and stick copper tape is an easy way to build a basic circuit, which is just a complete closed loop that electricity can travel around. The coin cell battery is your power source. It has a negative side and a positive side with the plus sign. Those tiny electrons we learned about earlier are all bunched up on the negative side, just waiting for a path to get to the positive side. When you stick down your copper tape, you create a conductive pathway, just like a wire. The electrons flow from the battery's negative terminal, through the copper tape, and then through the LED light. After passing through the LED, the electrons continue along your second line of copper tape until they reach the positive terminal on the battery. As soon as the loop is complete, the LED lights up. You've safely harnessed the flow of the electrons and made art at the same time. Now for the moment you've been waiting for. At the beginning of the episode, I asked if the rubber tires on your car keep you safe during a lightning storm. Well, that's a fallacy. While it's true you are safer in a car, the tires have almost nothing to do with it. A lightning bolt has just traveled miles through the air, which is a fantastic insulator. A few inches of rubber aren't going to do much to stop it. The real reason you're safe in your car is that your car's metal body acts as a Faraday cage. This means the metal conducts the electricity around the outside of the car, and the electric charge safely passes over the metal shell and into the ground, leaving the inside where you are completely untouched. So ironically, you're protected by the conductor, the car's metal shell, not the rubber tires or any insulators. Now, I hope you enjoyed learning a bit about electricity with me today. Be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.